pleasure to be presenting at SUMSF. This, as I mentioned a moment ago, this started back in 2009, MMCD Infrastructure Data Standards, as a CAD standardization initiative, and has since evolved into an asset management initiative with an emphasis on post-construction data submittals. And I just want to make a note about Jeff. I met Jeff probably, over 10 years ago, 12 years ago. I think we presented this at, I believe it was a EURISA conference. And Jeff, being the visionary that he was, I mean, he had his hands into everything. And this is really about data collection, you know, at the end of a project. And so he was tuned into the all-encompassing needs of data governance and being on top of your records. So back in the late noughties, I guess, in 2008, tangible capital assets was a thing. The PSAB 3150 accounting standard was introduced, and local governments were scrambling to figure out the state of their infrastructure, what they had, you know, where was it, and what was its condition. And so over time, those records became improved through various data collection initiatives, reconnaissance initiatives. But what was happening was that infrastructure is changing on a daily basis through capital programs, through land development, through maintenance and operations activities, and even through reactionary work due to unforeseen events. And I'll come back to the picture on this slide here in a moment. So I'll just run through a quick agenda. I want to talk about why MMCD is good for IDS and what it exactly is infrastructure data standards. We'll discuss current practices for updating local government databases. We'll talk about construction recorded data submittals, the mechanism in place for how this all works. Talk about our data delivery specification. So what does the model look like? The consumption of infrastructure data at the end of the project, how does that look? Why is it important? And then we'll talk a little bit about the drivers for a common standard. And just going to end the presentation or the discussion off with tying this in and relating it to building information modeling. So why is MMCD good for IDS? So MMCD is British Columbia's Master Municipal Construction Documents Association. And they were founded in the mid-90s as a nonprofit organization to bring standardization to both infrastructure specifications and contract documents, you know, essentially between the owner and the contractor. And, you know, BC has approximately, I think it's 200 local governments and the same number of First Nation communities. And it makes sense to have standardization, right? So why reinvent the wheels if we can have standardized specifications for infrastructure and also contract documents? And I think there's probably, 60 to 70 local governments right now are fully enveloped in using these standards. It's member-driven and funded. It's by owners, by engineers and contractors, and the board. The executive board is represented by the Ministry of Transportation, engineer and geoscientists of BC road builders, the provincial government, owners, consultants, and contractors. So MMCD is an established organization with history and membership. And that really is the key because you need this sort of initiative to be supported by an organization. And just here in BC, you know, I've been doing this for, I've been in the business as a consultant for about 30 years. And over the years, I've seen various groups of locally collected municipalities in the southern Vancouver Island and the BC interior. A bunch of people get together and they have a great idea. Let's have a common language. But those are ideas of individuals. Individuals move on. And I think it's really important to have an organization that can support this sort of standard. So we're lucky that MMCD is here. And the infrastructure data standards also dovetail perfectly with infrastructure specs and contracts. And, you know, I think somebody mentioned it earlier, you start providing standards and tools the floodgates open with the opportunities. Oh, what about doing this? What about doing this? So what about standardized quantity takeoffs to automate the population of an MMCD standardized contract document from your design model drawings? And I mean, I won't, the list goes on and on for the potential here, but yeah, it's a perfect fit basically. So IDS, Infrastructure Data Standards, essentially is consistency. It brings consistency with the tools for the preparation of the designs, because it all starts with the design, the tender drawings, and then the post-construction data deliverables. So the tagline here as an asset management initiative is, how can you manage your assets if you don't have the data? So once again, after PSAB and tangible capital assets was introduced, the emphasis and the push was to figure out the state of your current infrastructure. But, cities like Kelowna and Burnaby, very, very quickly changing. Burnaby more so through replacing aging infrastructure that it's at the end of its useful life. And Kelowna, it's all about land development. Kelowna, I believe, is one of the quickest growing municipalities still in Canada. So as I mentioned, it was founded in 2009, Standards for Infrastructure Procurement and Lifecycle Management. It's built on Civil 3D. So once again, we are fortunate in BC in that the majority of consultants are using Autodesk Civil 3D as a design tool. And really where the light bulb went off back in the day was when you're designing a pipe network, a water main, a sanitary, a storm sewer, Civil 3D it's AutoCAD is just kind of dumb lines and arcs and polylines and text. Civil 3D is design objects that have physical properties, materials, diameters, grades, locations, all these physical properties that are obviously of interest. So that was where the trigger went off. GIS data extraction. So we can produce, City of Burnaby can produce MMCD standardized documents for response and planning. Somebody mentioned earlier about, I think it was the keynote, about accuracy. Obviously, GIS data is not going to be used for detailed design, but for planning, preliminary design, conceptual design, 100%. We have standards for survey codes that tie to the symbols, that tie to the layers and the line types. Infrastructure design modeling standards, so using the tool, Civil 3D tool, that's what we're doing right now. We're modeling and we're producing. So two separate roles, two separate tasks: design, modeling, drawing, production. And then this is the big one that's got the attention: standardize, what we call construction recorded data delivery to the local government at the end of the project. And then we also have this asset management data register as one of the components, and I'll talk about that shortly. So that's kind of summarizes what IDS consists of, and it is free. Membership is encouraged, but it's freeware. It's hard to lock down a CAD standard, so to say. So with that, there's been significant uptake. So let's just change gears here and look at a typical project procurement. So in the middle, we've got the red asset register. Most local governments, it's your GIS. There's other databases, relational systems, but that's really kind of our primary intake mechanism for data. We might have information in our GIS that allows our asset managers to be proactive and do capital planning. Each project then goes into a preliminary design using data from the GIS, then a topographic survey, a detailed design. We construct, we collect information on what was built, and then we submit that, closing the loop back to our GIS. And if we reshape those little bubbles into design modeling, drawing production, construction, data exchange, and asset management, those 5 brown boxes represent the suite of infrastructure data standards. So at the top of the hierarchy, we have what we call the municipal CAD standard. So essentially, that's where you do your design modeling. That's the Civil 3D drawing templates with all of the AutoCAD standardized components and all of the Civil 3D standardized components and all of the supporting files. 3 subsets of that are the drawing production standards. So Civil 3D is set up with styles that will automate the label of a manhole, of a pipe, of a vertical curve. And with that, we can get consistency with the look and the feel of construction drawings. So one of the things that really amazed me back in the day was you'd go to a Burnaby set of drawings, and then to a new Westminster, and then to a City of Victoria, and all of the drawings presented information differently. And so we can now have a drawing production standard by virtue of our toolbox, which is at the top of the list. The construction standard represents, obviously a level of detail for our models. So we're producing real design models, properly scaled, properly spatially coordinated. And the construction standard dictates that level of detail for construction. Are you over modeling? What information do we require from a pipe network, a pressure network, a corridor model for roadway design that allows us to extract data for construction? The data exchange standard is what we need at the end of the day, what the local government is asking for. Standards for post-construction data deliverables. So this is the toolkit at the top of the list. And then we've got these 3 substandards that are not substandard, but standards that are underneath the design modeling standard that cannot exist without that toolkit. And then at the end, we've got the asset management, and that's where things like historical cost, condition, expected life comes into play. So what are the attributes that we should be tracking in order for asset managers to do their job? And that is going to then tie into the data exchange standard. So what we need to do our jobs with our data dictates what we ask for at the end of the project. So that's kind of the five levels of standardization for IDS. So it's really important to understand the pain that local governments experience with updating their GIS based on projects. So let's just talk a little bit about current practices. So not uncommon, redrawing graphics in GIS. So we have GIS technicians. GIS is a spatial, a graphical application, and we get the hard copy as-built with the red line markups. And even in today's day and age, this is a very prevalent practice. And the main reason it's prevalent is because we don't have CAD standardization. So that's first and foremost, that's happening a lot. If we're lucky, maybe the graphics are spatially coordinated to the right coordinate zone using the right coordinates, correct scale factors. We can import the graphics and then do some cleanup in the GIS. Definitely, we need manual attribution. So what's the diameter of the pipe? What's the material? What's its condition? Who was the contractor? Maybe what was the cost to install that piece of pipe or that manhole? And then that's kind of called, that's analogous to a method that Burnaby, so the city of Burnaby, second largest municipality in BC, were instrumental in getting this asset data exchange going back in 2016. They were replacing an old label and table method. And the way that looked was that we would make a copy of the engineering drawing below that you see here. You'd strip out all the annotations, you'd strip out all the title blocks, you'd put a bubble leader to each asset type that you're tracking, and then in a corresponding spreadsheet, you would fill out all the properties, right, for each asset type. So that happened at the design end, and then the deliverable was a PDF with a spreadsheet, and then somebody at the GIS would regurgitate, retype, and transpose that data. Costly, time-consuming, and prone to errors. And it didn't really account for removed or abandoned assets. So it's interesting that the local governments that have been around for a while, like I mentioned, Burnaby, the bulk of their capital program is to remove assets that are, or abandon them that are at the end of their useful life. So this whole process then becomes further complicated with a lack of drafting standards. So really, like I said, it was founded as a CAD standard, with Civil 3D being, the infrastructure flavored version of AutoCAD that really allowed for proper design modeling to be happening. But all of this just became further complicated. So the end result is that to this day, many local governments are still redrawing information. So how does it work? How does MMCD IDS work? Well, basically, it starts with the design. And that's, like I said, where the light bulb went off. It's like, well, we're designing using these pressure networks and gravity networks in Civil 3D, and look at all of these properties. It's all there. So it does start with the design. And once again, just for those of you who might be unfamiliar, we're no longer drafting just with lines and arcs in AutoCAD. We're using design modeling tools that have 3D capabilities with specific parts for manholes and fittings and pipes. And that task now is design modeling. Back in the day, it was design and drafting. Now we're design modeling and we're producing drawings. So those are two distinct roles. What we've seen over the years is that the traditional role of designer and drafter, many cases in an optimal world, they have converged. So oftentimes it's the design modeler does their own drawing production. And that does become facilitated with a tool like Civil 3D, because we have these label styles that pull the properties from the objects that will properly annotate and consistently annotate on your production drawings. So we keep them separate. We've got the design model data, and then we have our production drawings, and we share the data between the two in a simplified, that's just a simplified explanation, but there's tools for sharing data so that we can keep that separate. And in a large project, you can still have drawing production staff and design modeling staff. And all of those data sharing mechanisms, it's got to be organized. Let me just back up here. And back in the day, I remember I started as a transportation engineer when I came out to BC in 1995. And we worked for, I was working for a consultant, and we were doing a project for a lower mainland local government. And they asked me for my plan profile drawings, the DWGs at the end of the project. I'm like, well, why would you, you don't really want to give that stuff over, especially if your engineer's seal is on it. And it didn't make much sense. And, but that was how the digital drawing manifested itself back in the day. You drew the plan and the profile, and that's where all the information resided. But we're not emphasizing that. So right now it's all about the design model data, right? That's the important part. So how does the mechanism work? Well, we have modeled our proposed project in Autodesk Civil 3D. At the end of the project, once the design has been submitted and construction is finished, we can copy that design model drawing, and let's rename that to construction recorded. So that's the record that now duplicates the design, but it's been renamed construction recorded. And that construction recorded design model DWG. So the DWG is just the file format for an AutoCAD drawing, a Civil 3D drawing. So that construction recorded drawing is then updated. What do we do? We remove all the title blocks. We don't need the title blocks anymore. We remove all of the engineering annotations in the notes. We update that model to reflect what was built. Okay, so we changed the location of a manhole. We updated our invert elevations. We added another catch basin and a lead. And that information is sourced from the traditional as-built drawing. So this process is not duplicating the as-built process. It's an additional process, an additional workflow to update the GIS, to update your asset register. The as-built process is still something that is, where you have a hard copy PDF sealed by an engineer with markups indicating, okay, what have we actually built? That's the legal document that will stand up in court. Now, having said that, there's another potential, right? So there's another potential where this thing can go. And the as-built drawing, essentially, right now, it's a vehicle. So that's what we work with. See, okay, what changed? It's the record. It's the record drawing. So two separate things still, and for a while, but potential to bring that all together with digital certifications, certifying data. Okay, and then at the end, we add additional attribution. So attribution beyond what is in the Civil 3D model. So a Civil 3D pipe might have the physical properties, but maybe we want to know the contractor. Maybe we want to know its life expectancy. Maybe we want to know what that piece of infrastructure costed, and other attributes. And it's not all about Civil 3D. There's many asset types that are represented with just an AutoCAD block, or even a line or a polyline representing a closed polyline representing a new area of paved, either full depth reconstruction or just resurfacing, but we can attribute that using other attribution tools. So there's adding the additional attribution is the final component. And then, so what does that data delivery specification or that model look like? So really, it's a list of asset types. And so this is what we're going through with Kelowna right now. What assets do we need to collect information on? After that, it's what attributes or properties do we need for each asset type? And then for each of those attribute or properties, what are the allowable values? Right? So it's all about the consistency. And then feature representation. So I just touched on this. So in that submitted drawing, how are you going to actually represent that in that actual file? Is it an AutoCAD block entity? Is it an AutoCAD polyline? Or is it a Civil 3D fitting, a Civil 3D structure, a Civil 3D pipe, or a pressure pipe? And then a little bit more detail on how that gets represented in that file. So that's really what the specification looks like. And what we have essentially, how does that manifest itself? It's a bunch of hard copy tables where it talks about the specifics of how that feature is to be represented, all of the attributes, and all of the allowable attribute values. All right. And then here you see a table. This is actually using, believe it or not, object data from, legacy, I believe. Maybe some of you have been around Canotech back in the late 80s, early 90s. That object data functionality is still widely used. It's part of Map 3D, and that's what we're using for some of these additional attributes. The plan is to update and move on from object data and embrace the newer property sets, which is another means of attributing information in AutoCAD. But once again, it all starts with a design. And that image from Burnaby is what was submitted. That's a screen capture of the DWG that was submitted after construction. Very simple. Once you remove all the notes, all the background information, the polylines you see there represent sidewalks and various pavement structure treatments, and then you have it was a water main project. So very, very simple, reduced drawing. And when you look at it, you get an immediate picture of what was done. Okay. You can also account for removed or abandoned assets. So, this once again with the city of Burnaby, 80% of their capital program was replacing old infrastructure that was at the end of its useful life. And the Burnaby initiative was driven by finance. And I'm going to talk about the drivers for this particular initiative, or the variability of the drivers. But finance basically said, we need data. And they wanted it on the books during design, for whatever financial reasons that I don't claim to understand, but they wanted to get it on the books early. But what Burnaby then did is they have a self-serve tool, and the engineer can go to their GIS, and it's all with FME. I'm going to talk about FME, safe software, here in a moment, integral tool for all of this. But the engineer could go to the Burnaby's GIS, window an area, and you'd get the aerial photographs, and then you would get an MMCD formatted AutoCAD drawing, which we call existing recorded assets. So this is the record of what the city has on file, if you will. And that's all MMCD formatted with the same object data tables. And then what the consultant would do is they would take the service status of the infrastructure that was affected by the project in that file and then update it. So it's I for in service, or now it's RMVD for removed, or ABND for abandoned. And so that's how the mechanism worked for taking infrastructure off the books, so to say. All right, so now we have that standardized deliverable, and once again, more potential here. So now, how do we consume that? Well, really, once safe software. What can I say? I mean, it's our own backyard here, and we actually, when we started getting going on this in the early like 2011 or 12, we approached Safe Software, and at the time they didn't support the Civil 3D object model. Let Dale Lutz know what we were doing, and he got it and immediately supports now Civil 3D objects. So Safe Software, really, in my mind, is the only current, I guess, tool that will holistically and all-encompassingly consume our construction recorded data deliverables. You can attribute anything by virtue of a color. If it's a line, it could be a raised barrier curve. It's a polyline. It could be a mountable barrier curve. Infinite ways to attribute, because a lot of our features that we're submitting are not just Civil 3D. We would have polylines and then block names, and Safe can just look at it all basically. So that's one of the benefits that we have here now. Just let me back up here of having we have software consistency in the province, not over the whole map, but like I said, most consultants, most designers, most engineers are using Civil 3D. And the reality is that most local governments, with the exception of some of the smaller ones, are using Esri. So what we can do now with FME, and there's this, once again, the potential, the floodgates open for the potential, is that FME uses what's called a workspace to translate our construction recorded drawing to an Esri geodatabase. It's a standardized workspace that looks for certain features on certain layers that have certain names. And we can now provide that as a tool. So this is out there. I mean, once again, Burnaby's got this developed. They want to share it, but that could become part of our standardized offering. So once you talk the same language, like I said, the floodgates open. Now, having said that, in the last few years, Autodesk and Esri have formed somewhat of a relationship, and which is good news, right? Now the major players, Autodesk can write to Esri geodatabase formats, and Esri can consume Civil 3D data. However, once again, it's fairly new, last couple of years type of thing. Definitely keeping our eye on this, but that holds promise for the future. What I do find really interesting is that when I started working when I graduated from university and started working as a young engineer, when we were just coming off Mylar and Ink and going to CAD in the early 90s, the discussion after we were into CAD for a while was CAD and GIS integration, right? That was a hot topic. Here we are 30 years later, and the discussion is about CAD and GIS integration. And I think, Safe Software is playing a key role, obviously, but Autodesk and Esri being, kind of the industry leaders in their respective domains, is holding promise for the future. Okay, why is all this important? Why are we doing this? It's really about resilience. So for those of you who are in BC, or you may remember back in 2021, we had some pretty devastating rainfall events. City of Abbotsford was flooded. A lot of the Sea to Sky Highway, the Coquihalla bridges washed out. In major transportation corridors, major disruption to infrastructure. This is only 3 years ago, and I started doing a little research on natural disasters, and then you look at Fort McMurray, and you look at the ice storm back in 1998, and the South Alberta floods, and the list goes on. I mean, these are just natural disasters. These are Mother Nature wreaking havoc on us. Let alone, the fact that out here in the West Coast, we've got this looming mega thrust earthquake with tsunami hazards due. It's a reality. I mean, it might not happen in my lifetime, but if you look at the history, the proven history, it will happen again. Something like magnitude 9, right? Which is a major event. And what's going to happen as a result of that. So really, we need to have we need information on our data. When I started doing this a couple of years ago, another form of this presentation, I just read about a Canadian fella who was sentenced 20 years in the US for ransomware attacks. going after companies, municipalities, hospitals, emergency services, schools, colleges, universities. So that's a real threat as well. Not really relating to this initiative, but it's all about data governance, right? It's all encompassing. MMCD focuses on the delivery of the data, but once you get that, and then just recently, a major Canadian city had a water main rupture, a major water main, which wreaked havoc. So that's the aging infrastructure side of things. So, data is an asset, and we need to treat it as such. We need to treat the data on our assets in the same way that we treat our assets. And resilience is synonymous with critical built asset reliability. You can spin that around and say it's vulnerability. And local government. So this is all about local government, right? I mean, it's local government infrastructure. That's this initiative. We need resilient-based strategies that make us less vulnerable. And what I find interesting watching the variety of presentations today, we're all kind of talking different spaces and a little very similar, but very different, but very commonly themed, right? So innovations in technology and processes strengthen resilience. With FME, what Burnaby's starting to do now is we can automate the intake of post-construction data. An FME server can do an automated check or accept or reject a submission based on compliance with the standard. So that once again, once you create standardization, my gosh, the opportunities just seem to continually present themselves here. And really, the rules applicable to financial information should be applicable to asset data. So finance is required to account for infrastructure now by law as a result of TCA. Australia, asset management is legislated, right? So I think that we need to step up our requirements here. The age-old 2-year as-built backlog, right? Often the data ends up on somebody's table, and you get to it when you get to it. But really, right out of Australia's IIM manual from Institute of Public Works and Engineering, it's never going to be cheaper and more efficient to get complete and accurate data other than at the time of commissioning. No point in chasing it down 2 years from now. Let's get it as part of the project. And we have tools to enforce that. For infrastructure projects, we have contracts between the owner and the engineer. And for land development, a bit trickier, but we have the City of Kelowna is tying currently they're tying their as-built or their record drawings, okay, to completion certificates. So once the development passes substantial completion, then essentially the developer gets their bond back. And substantial completion now includes the submission of record drawing data. And we're going to be updating what's called, we have the City of Kelowna that we're working with right now has an administrative policy that is, once again, an official document that's part of the organization that will require and outline the high-level requirements for data submissions, but that will reference then what we're going to have is an infrastructure data standards manual. So what's interesting about this initiative, just from personal experience, finance and accounting was behind this for the city of Burnaby back in 2016. City of Prince George, it was asset management. So Frank Blues was the original asset manager up there, and they get a new lady there, and Christy Bobby, and she's doing asset management, but they had some studies done, and well, basically, if you really want to do asset management properly, you need to collect the data. District of Saanich, consistent engineering workflows, However, they also want to move into the asset management as well and start using this as a vehicle to provide data for asset management. City of Kelowna, staffing resources, right? So they're growing. That's where we're currently working with, growing so fast, and they cannot keep up due to the processes of label and table and getting whatever you get at the end of the day from whatever consultant. You can't redraw everything with growing so fast. And so their IT department said, we need to get on top of this. We need to automate and we need to standardize and automate our data deliverables. So let alone the fact that, when you look at the roles of a local government, many have a vested interest in correct and current infrastructure data. If the data doesn't get in until 2 years later and then somebody goes to a GIS, they're not going to use it, right? Oh, we're missing this. I just was working on a project last year here. It's not there. They don't trust it. So they go back to their own records. So what's the cost of outdated, missing, or incomplete information? You can't make good decisions. You can't plan. You can't react. You can't do your work properly. And mistakes can happen, costly mistakes in some cases. So we've had quite a bit of success with this. This is what I do all the time. And sometimes I think we should be further ahead. But this is just a little piece of what, local government and administrators are doing all the time. This is just one little component of the many things they need to deal with. But definitely we've had some success. A lot of it has been driven by the local governments. MMCD is it's a nonprofit and we have membership dues, but we're trying to figure out more creative ways to fund IDS. Just it's kind of like we built this now, and now we owe it to the community to be able to deliver and to continue to improve and get involved with groups like this, and share the data. And also, I've always said it's the local governments, it's the hiring agencies that set the standard and make the rules. With MMCD now, these local governments can now go to an off-the-shelf standard, if you will, and say, listen, if you're going to work for us, you need to use our tools. And raising the bar, right? So we're raising the bar and using the functionality, and the technology has been around for a while. But where's the real driver? It's coming from the hiring agencies. And the same thing, I'm also working with the Ministry of Transportation as a senior consultant to implement Civil 3D. It's all the same thing, but it's data for construction. Their emphasis is data for all of their construction supervision workflows. And they have a very high bar for how data is to be submitted. You can use it off the shelf, right? So there's a lot of local governments that don't have internal CAD capabilities. You can use it off the shelf. If you want to work for us, use the MMCD standard. And just finally, it is BIM, building information modeling. That's essentially what we're doing. This is very much a BIM initiative. And, it's a digitalization of the built asset industry. I don't need to get into this in too much detail, but open international standards and solutions. And if you go to Building Smart Canada's website, they've got a document on BIM for municipalities, and it does center around asset management. So that's it for now. MMCD, you can go download these standards and the documentation. We're actually amidst an update right now. We're going to be the last update was done in 2022. We're doing a fairly major update this year. And a part of that is going to be a data delivery specification, an off-the-shelf data delivery specification that we can add. It'll be a standardized MMCD document, but that could then be added as a supplemental optional specification for an owner who wants to have data submitted at the end of a project in a certain manner. So we'll be updating the drawing templates and all of the traditional tools, but we're also developing this specification as an official MMCD document.
What type, if any, of geolocation document recording does MMCD support?
This is typically done by, there's nothing is prescribed with regards to collecting information on existing recorded assets. Oftentimes what local governments have done is they've hired surveyors to go out and survey information within specified tolerances that's driven by their GIS. But MMCD really focuses on, the data delivery at the end of the project. So we have to be and it starts with the design. So we have to be spatially coordinated. And then the collection of information upon which the design is going to be based would have been done by total station or GPS within detailed design tolerances. And then at the end of the project, we're finding that we may survey, like, say, the onus is on the contractor to provide the information. The inspector, or the engineer cannot be on site 24/7 watching every, little bit of construction. So what the contractor might survey data, or they might even mark up the engineering drawings for the basis of the record data submission to indicate how something is moved or changed. So that's really it from a data collection perspective. It's typically field measurements and survey field measurements, manual field measurements, or surveyed field measurements.
Great. And we've got another question here from Julie. Regarding resilience, are you considering using non-proprietary softwares or IFC?
That is definitely on, IFC is definitely on the radar. Once again, this is, we're taking information from a design that based on current technologies, and really, safe software, FME, provides the mapping from our data delivery schema or model, if you will, to our GIS model. And that's largely dependent on what's kind of happening at each end. But, with industry foundation class, we're definitely keeping our eyes on these things. There's quite a few things that I think we need to approach here in the short term before we start going down that road, but absolutely.
Okay, great. There's another question here. How can MMCD continue to support IDS if it is not monetized?
Yeah, and that's been a bit of a challenge. What's been great is this has been a community-driven initiative. So anything that is developed by a requirement by a local government, i.e., this asset data exchange standard, that gets fed back into the standardized offering. But like I said, there's so many more things that we can do. And I think that what we're planning on doing in the future here is getting support by local governments. And this has been suggested by a few of the local government managers. They say, well, we'll kick in, X amount of dollars, and we can set it up so that it's based on your population, let's say. So these local governments that have now got into this initiative want to see it continue, want to see it well supported. And we're not talking, tens of thousands of dollars. It might be a couple, 3,000, maybe 5,000 for the city of Surrey or something like that a year. I don't know what those numbers are yet, but that's what we're looking at doing, is now getting a contribution based on those who are actually using it.